Have you ever gazed up at the night sky and wondered why it's mostly black instead of glowing bright? At first glance, it seems odd. There are billions of stars out there. In the 19th century, astronomer Heinrich Olbers pointed out this paradox. If the universe were infinite, eternal, and filled uniformly with stars, then every line of sight should end on a star and the night sky would blaze with light. Clearly, that's not what we see. This contradiction, the darkness of the night sky, tells us that one or more of those assumptions must be wrong. One key to the mystery is that light has a finite speed. Light zooms through space at about 300,000 kilometers per second. Even so, it takes time to cross cosmic distances. For example, sunlight takes about 8 minutes to reach us, and light from the nearest star system, Alpha Centauri, takes 4.3 years. In general, the starlight we see today left its source long ago, often millions or billions of years in the past. In other words, when we look at very distant stars and galaxies, we are seeing them as they were ages ago, not as they are right now. There simply hasn't been enough time since the universe began for light from the farthest reaches to reach Earth. Those regions remain invisible. Their light is still on the way. Modern cosmology tells us the universe has a finite age. Measurements by satellites like WMAP and Planck give an age of about 13.8 billion years. This means the universe isn't infinitely old. It began in a hot Big Bang and has been evolving ever since. Because of this finite age, there is a limit to how far we can see. A cosmic horizon. Light from objects farther than about 13.8 billion light years hasn't had enough time to reach us yet. In effect, we're surrounded by a spherical horizon of visibility. Beyond that, there may be many stars, but their light is still traveling towards us, so part of the universe is simply beyond our view. The darkness isn't emptiness, it's the edge of what we can observe. Another crucial factor is that space itself is expanding. In 1929, Edwin Hubble discovered that nearly all galaxies are moving away from us. In an expanding universe, light waves get stretched out as they travel through space. This effect is called redshift. A galaxy's light shifts to longer, redder wavelengths the farther it is. For very distant galaxies, the shift is extreme. Their light, which may start out as visible or ultraviolet, ends up in the infrared or even radio range by the time it arrives. For example, recent observations with the James Webb Space Telescope show that some of the earliest galaxies have their ultraviolet light shifted deep into the infrared. Since our eyes can only see visible wavelengths, that stretched out light appears dark to us. Interstellar and intergalactic material also hide some light. Clouds of gas and dust between the stars can absorb and scatter visible light. When dust grains absorb starlight, mostly ultraviolet and visible, they heat up and then re-emit that energy as infrared or microwave radiation. This means some of the starlight is effectively hidden in wavelengths our eyes can't see. The result is a dimming of starlight. Astronomers call this interstellar extinction. In aggregate, this absorbed and re-emitted light contributes to a faint, cosmic infrared background, but it doesn't brighten the optical night sky. In fact, most of the background glow of the universe is now in microwaves. The Big Bang left behind a relic glow known as the cosmic microwave background. Missions like Planck have mapped this radiation, which is the afterglow from when the universe was about 380,000 years old. This primordial light has been redshifted so much by the expansion of space that it now fills the sky at microwave wavelengths. Human eyes cannot see microwaves, so the CMB is invisible to us. If we could see microwave light, the sky would not be dark at all, but uniformly bright with this ancient afterglow. As it is, we only see darkness in the visible range, even though in other wavelengths. Radio, microwave, infrared, the cosmos is indeed glowing. The darkness we see is just the limit of our vision, not a void of light.